is active, one port will become blocking. It's like a standby.
Oh, okay.
Now do one thing, the green one, right? That link, you just cancel, you delete that link. Now we'll wait for 20 seconds. Twenty times it will blink. Wait. Don't do anything. Don't do anything.
Oh, I'm back.
All right. Now what is happening? Why it is like this? So it is very important. We'll understand now.
Yeah,
What
this thing I mean lots of time I just check on server room and also in a server room or network room. So our secondary firewall is give this signal. I mean, that way we know which one working as a secondary is like a
yes,
same
exactly.
color.
Exactly. Now we'll talk about how it is happening. What is the process?
Class join course current. Okay.
Yeah, Mohammed.
Yeah, he's joining.
Okay. See, can you see the screen?
Yeah.
Okay. Now I'll do what? I have a switch one. So multiple PCs I have connected here. So again, multiple PCs I have connected to here. Switch 2. It is a switch 1, it isn't switch 2. Now this guy wanted to communicate with this guy, let's assume. So we need to what? We need to have a connectivity between these two switches. Right? Now in the switches, maybe some reason the port failure, or maybe you are doing some troubleshooting, you have removed that cable, you have connected that cable. Let's assume. Now both the switches, all the PCs will not communicate each other. Correct. Maybe it is the same office. So I'll do what? For redundancy purpose, we'll connect one more port. Now what happens if you connect like this? There is a looping. Now we called as layer 2 looping. Now when you connect one port, see there will be always advertisement every 2 seconds. These guys will start communicating each other. Now whenever I'll connect both the switches, so it will start exchanging the informations to the neighbor. Now I have connected switch 1 and switch 2. So maybe one guy will become a master. There will be election between the switches. So the election, one guy will become a root bridge. So root bridge is the master. You remember in BPDO we were talking, in the OSPF we are talking, right? So one will become a master, right? DR, BDR.
Yeah.
Okay. So we talked about DR, BDR, right? Similarly here, one guy will become a master. Master is nothing but root bridge. So root bridge will do what? Okay, I will send the information. See, my neighbor, you are my neighbor. So I have this switch. So this is a switch ID, all the information about this switch. So we called as BPDU. Bridge Protocol Data Unit talks about priority. So every switch have a priority. If you see in OSPF, in Cisco switch, by default, priority is what? 1, right? So similarly here, 32,768. See, BPDO is nothing but, so every 2 seconds, switches will send that BPDO. It is nothing but the switch information, bridge protocol data unit. He will inform about the switch. he will inform to the neighbor. You know, in routing protocol, what happens? All the protocol will start exchanging their informations to the neighbor. Right, okay, Ahmad?
Yeah, yeah.
Similarly, this guy also is saying his information where to the neighbor. So what is the information? See, in OSPF, recall. See, he was talking about router ID. He is introducing himself, right? Similarly, the switch, he is introducing himself. What he will introduce? He will introduce BPD, Bridge Protocol Data Unit. He will talk about priority, my priority. See, the priority will become same on all the Cisco switches, 32,768. Then it will also calculate the MAC address. So when the priority is same, it will check with the MAC address. So every 2 seconds, it will start exchanging his information, nothing but BPDO. Now he will receive, okay, my neighbor information. Then again, if you connect to this port, let's assume, now he is receiving information through on one port. Maybe it is a fast Ethernet 0/1 port. So FA 0/1 port. So we have connected through on FA 0/2. FA 0/2. Now we have received one information through an FA 0/1. So who is the neighbor of this port? FA 0/2 is also a neighbor, right? So same information. So about the switch 1 information, he will send to the switch 2 port with the FA 0/2 port. Again, FA 0/2 he will receive. Okay, my neighbor is, I have a neighbor, it is connected through on this port. Again, he will send the same informations to this guy. See what I'm receiving already, I have the information about switch 1. Again, he is sending through on the another port. So again, he will receive this. He doesn't know what he is sending. So my neighbor is, I have one more neighbor connected to switch 1. So he will send like this. Again, he will receive. Again, he will send. So this is nothing but we called as looping. So keep on, he will send a loop information. So in those moments, if somebody is sending the data request to other switch, so still there is a looping. So he will not send the packet. So that is the reason we have layer 2 looping. That is to stop the layer 2 looping, we have STP, spanning tree protocol. So what spanning tree protocol will do? He will identify, okay, this is a switch 1 and switch 2. Now which port is a forwarding port? Forwarding port in the sense through on which port you can send this information update. You can say bridge protocol data unit. There is an update. So which port? It has to be a forwarding port. And okay, again from the same switch I'm connecting to. So same switch. I'm connecting to the same switch. So which port will become a blocking? He will identify this. STP will identify. So one port will become blocking, one port will become active. Now how he will identify the blocking port? Right? How he will identify this blocking port? So first he'll identify the root bridge. So he will do the election. First he will identify root bridge. Now the question is who will become root bridge? So once he become a root bridge, the root bridge will send BPDU every 2 seconds. Now who will become root bridge? To become a root bridge, he will check it out. First thing, he will check it out priority. So this switch priority is 32,768. This priority is 32,768. I will check it out highest priority. So who is having the highest priority? That switch will become root bridge. Now tell me who is having highest priority in both the switches.
So far I know like both is same.
Both is same, right?
Yeah.
In both the switch priority is same. The next thing. In OSPF, we talked about, right? To identify the DR, he will identify priority. If all the router priority same, then what he will do? He will look for IP address, right? In the OSPF.
Yeah.
But switch, it will work based on what? MAC address. He'll check it out who is highest.
How to check the highest MAC address? Because MAC address is like
in the hexadecimal you will get, right? It will check
number.
it out the last number.
Okay. Yeah, obviously, since this is the number, there will be highest or lowest.
Okay, let's assume. So this MAC address, switch MAC address is 0B. This is 0A. So who is the highest MAC address here?
Suppose 0B.
No, maybe based on something else.
I mean, 0 and 0B, whatever value is more, he will be the highest.
The highest will become what? B0 will be the highest, right?
We didn't know, thinking actually.
Here, so in the case of OSPF, it will check with the priority. Here also priority, it will check with the priority. See, in case of switch, it's a lowest priority.
Oh, okay.
Who is the lowest priority? Similarly, who is having a lowest MAC address? Lowest MAC. Now you tell me, who is having a lowest MAC address?
A0.
A0. Or as in case you can do what? You can also manually specify. See, sometimes what happens, MAC address, there is a software available. You can use the software, you can change the MAC address. So if you change a MAC address, again root bridge will become changed. So you can also assign system ID manually. See, I told in OSPF, either you can go with what? Priority, highest priority. If all the highest priority means all the priority is same, it will go with highest MAC address. Sorry, highest IP address. In case the IP address, if you don't know IP address, you can assign router ID, right? Do you remember? Similarly, here we have a system ID. So if you don't want search based on the MAC address, you can specify system ID. You can manually assign this.
Go on, guess it.
The system ID is nothing but VLAN ID based on the VLAN ID. So it will identify. First, it will check it out. Do you have any system ID? Then it will go with priority. Then it
how
will check
it works. I mean, how depending on VLAN system ID, that means lowest or highest?
Yeah, everything is a lowest.
Okay, and the switch everything is a lowest.
Yes, switch, in the case of switch, it's a lowest. In the case of router, it's highest. Okay, now he is becoming root bridge. Now what he will do, every 2 seconds, he will send that BPDU to the neighbor. Who's having a neighbor? Is a neighbor. Now we'll take in 3 switch example. Suppose here I have a 1 switch. Switch 1, maybe a switch 2. Here I have switch 3. I have connected all the 3 switch. Now here I have a root bridge. Now he will do what? He will generate a BPDU. He will send. See, my neighbor is, who is my neighbor? Switch 1 is sending information. So my neighbor is switch 3 from the switch 1. So like that he will send an information. He'll receive it. He has to send that information to the neighbor, right? He will send to the neighbor. Boss, my neighbor is switch 1. I'm sending from switch 2. So he will receive. He'll update. Then he also has to send an update to the neighbor, right? So whenever he will receive an update, he will always send to the neighbor. He will also send update to the neighbor. What? I'm switch 3. My neighbor is switch 2. Again, he will receive this update. He is sending, whenever he is receiving something, he has to send it to the neighbor. See, somebody is giving something to me, I have to give to the next person. So like that. So he's received some information, he has to send it to, is it not required, right? It's not required. Already he received the update. Again, he will send the update to the neighbor, same information. So my neighbor is switch 3. So I'm in from switch 1. So already received, he will send. Again, that information will pass to the neighbor. So I've received from the neighbor something, I have to send it to my neighbor. So this is what the looping is called. To stop sending looping information, first I have to identify bridge. You no need to do anything. The switch will calculate, switch will do the election. It will identify the root bridge. So once it is identifying the root bridge, then it has to find out so which port are forwarding port and which ports are blocking port. So in these 3 switches. Okay, maybe a MAC address. So the MAC address is A0 and maybe your, okay, this switch 2 and it is switch 1. Maybe here I have switch 3. Let's first specify the MAC address. 0A or it is 110B, 0C. Now who is having who will become root bridge here? Who will become root bridge?
0A, thank you.
So he will become root bridge. Now once it is finding a root bridge, then he has to identify, root bridge has to identify which is forwarding port and which is blocking port. So STP, it will do the STP process. In the STP process, it will identify root port. So root port is nothing but it's a forwarding port. And also it will identify the designated port. It's a DP port. So whenever it's mentioning it's a DP port, it is also forward the packet, forward the updates. Then third port, it will identify blocking. So blocking port, it will stop sending and receiving any packets. Now the question is, who will become root port? There is a criteria to identify the root port.
What is the meaning of DP?
So designated port.
Okay.
Designated port is also
this
forward.
DP, I just saw one of the converter like HDMI to USB-C port, that adapter, actually that adapter has one of the port. It looks like C type, but it is written as a DP.
No, that is the data protection maybe. This is the internal process.
Okay.
It may change. So maybe this port will become DP port, let's assume. Later on, some port will become DP port based on the election. So you have to identify, now, in this 3 switches, there is a looping, right? So to identify which port is blocking port, right? There will be an election and the STP process will run. Root bridge will identify, root bridge will run this process to identify which port is forwarding port, which port is blocking port. Okay. Now to identify the root port, so always it will go with non-root bridge. Now which switch will become non-root bridge? Here in this 3 switches, which switch are non-root bridge switches? Switch 1 is a root bridge, right? Now switch 2 and switch 3 will be a non-root bridge. switches, right? These are all non-root bridge. So this is non-root bridge, right? Okay, Ahmad?
Yeah.
Now, in the non-root bridge, now which port is connected to reach to the root bridge? Which switch is a root bridge? Switch 1 is a root bridge, right? Now tell me, in this non-root bridge, which port is connected to root bridge? Which port is connected to root bridge?
FA0/1, FA0/.
Okay, I'll mention FA0/0. It is FA0/1. It is FA0/0. Maybe if it is 0/1. It is also FA0/0/1. Now tell me which port will be a in the non-root bridge. Which port?
FA0/0 and 0/1.
Exactly, right? In switch 2, FA0/0 port, and in this switch 3, FA0/0 port will be near to root bridge, right? Am I confusing? Okay, Ahmad.
No,
Very
I
simple.
mean, I think.
Can you repeat it again one time?
See, whenever the switch you are connecting, switches will do the election to identify the root bridge. Right? Root bridge. Now this switch is a root bridge. Now it will, once it is identifying a root bridge, it will run the STB process. First, it will start identifying a root port. Now, which port will become root port? So that to identify the root port, it will check it out non-root bridge. So non-root bridge. Okay, these two switches are non-root bridge, right?
Yeah.
Now, the first thing is it will identify near port to root bridge. From the non-root bridge, near port to root bridge. Which is the near port to root bridge? From the switch to, from the switch to FA0/0 port is near to root bridge. From the switch to, so FA0/0 will be near to root bridge, right? Now these two port will become root port. It's a root port. Clear?
FA0/0, yeah.
So this is near to root bridge. It's a root port. And also it will check it out. There is a pathcast value. So near to port, immediately it will not become root port. Okay, this is near port. In this near port, again it will check it out. Second thing, pathcast value. So port connected to the root bridge, calculate with the cast value. So now this port, what is the speed of this port? So there is a pathcast value. Suppose pathcast So every port have a pathcast value. In case if you have a 100 Mbps port, the pathcast value will become 19. So in case of it is 10 Mbps, the pathcast value is 100. If it is a gigabit port, the pathcast value will become 1 gigabit. If it is a 10 gigabit ports, the pathcast value will become 1. Now let's assume this is a 100 Mbps port. So pathcast value, it will check it out the pathcast value. So pathcast value is 19. Now same pathcast value here. So it will check it out pathcast value. Now both the pathcast value is same. Then third, it will check it out based on port number, port speed. So based on the port number. Now I have one of the switch. Let's assume this pathcast value is maybe I have 19. And here port, the pathcast value will become 19. Now in this, maybe I'm connected to this port number 1. I've connected to the switch port number 2. Now, which is the lowest port ID? So that will become root port. Now we'll come back here. Suppose, so I need to identify, maybe I have a multiple switches, multiple ports are connected. Let's assume I have one of the port, one more port is connected here. For example, now in this 2 ports, again, which port will become root port? How you will identify? So again, there will be a looping, right? Okay, Ahmad, if I connect one switch to another switch like this, so there will be a looping here. To identify that is the reason they'll go with root port, and it will identify which port will become forwarding port. To identify, it will check it out. First, near port to the root bridge. Okay, these 2 ports are near port. Immediately, this port will not become root port. Check it out, the pathcast value. Now, both the pathcast values same. Then it will identify based on lowest port number. Maybe I have connected to this port number 1. This is connected to the port number 2. Now this port will become root port. So root port is nothing but forwarding port. It will forward the packets. Fine, clear? Okay, Ahmad. These 2 ports are root port now. Now again, we'll come back. We have a remaining 2 port, right? Remaining 2 ports. It is in non-root bridge. We have 1 more ports in non-root bridge. Now again, we have to identify the DP port and blocking ports. So to identify the DP port, so here we'll come back to DP. It will check it out the forwarding state. So every segment. So lowest bridge ID. Now lowest bridge ID will become DP port. Lowest bridge ID in the sense, bridge ID. So in the switches, which is the lowest bridge ID? It will identify first priority value. Both the switches priority is same. Then second thing is, it will identify what? Lowest MAC address. So that will become bridge, a root bridge. That is a secondary, the root bridge. So lowest bridge ID. So this is nothing but the bridge ID. So which switch is having a lowest bridge ID in these 2 switches? Okay, Ahmad. Check it out, priority. MAC address, right? MAC address, which is having a lowest in these 2 switches. Who is having lowest? Switch 2. It's the lowest. So this port will become DP port. So this 2 port, this will become DP port. Okay, to identify the blocking port. So once it is identifying a root port and the DP port, remaining whatever the port you have, that will become blocking. So this port will become blocking port. To do this election, it will take 30 seconds. To identify the STP process, it will take 30 seconds. Till that 30 seconds, once you connect to this port, immediately it will show amber. So once it is identifying the RP port, DB port, then blocking port, so then the color code will change. Once it is identifying RP port, it will become green. Once it is identifying a DB port, it will become green. So once it is identifying a blocking port, that color will not change. It will stick in amber, not red. Red in the sense the port is not working, but it will become amber. Now when it will become green, when it will become forwarding port, any of the port failure, if any of the port fails, immediately, not immediately, again it will identify which port is RP port, which port is DP port. Then it will become root port, forwarding port. So this will become DP. So this will become bridge ID will change. This will become again, so RP port, like that. Okay, go back to the lab, connect 3 switches, connect like this. Okay. We'll see in the lab.
Okay.